Hi there, I'm Keith Cawley, and this is Thrive, a Bridgestone Americas podcast where we explore our company through compelling conversations with teammates across our organization. We are focused on pioneering smarter, more sustainable products and solutions to support this evolving world of mobility. But beyond that, we are also working to be smarter and more sustainable in how we make things. A key part of our Bridgestone 3.0 journey is accelerating smart and green manufacturing across our entire footprint to drive operational efficiency, safety, and beyond. Today, we explore the smart side of these manufacturing efforts with Joe Wilson and Andy Warren, two Bridgestone teammates who are leveraging extended reality, 3D mapping, robot dogs, and so much more to drive new ways of thinking and working in our plants. We hope you enjoy this conversation. Well, we are joined today by two guys who are from our manufacturing world, but really involved in modernizing, advancing a lot of the aspects of our manufacturing facilities. So we are joined in the middle here by Joe Wilson, Director of Maintenance and Plant Support for Bridgestone Americas. Joe, thanks for joining us.
Thank you for having me.
Absolutely. And across the table is Andy Warren, Senior Manager of Engineering Services Support at Bridgestone Americas. Right, Andy?
Thank you. Yes, sir.
Absolutely. And I had to ask what ESS is, but it's on his shirt if we reference ESS at any point to make sure that people know what we're talking about. But we always like to start with a little bit of background on our guests to understand where you've been, where you are right now in the world of Bridgestone, and maybe why you're talking about the things we're talking about. But let's go, Joe, with you to start. What's your career journey been like, and how'd you get to where you are?
All right. Well, I grew up in an Air Force family. Naturally, I wanted to go to the military. I spent 8 years in the United States Army. I left the Army. I joined Tier 1 Automotive after I left the Army, ironically making cast aluminum wheels.
Okay.
So
already into the area.
Interesting start there. Then I spent some time with Ingersoll Rand, and ultimately with Ingersoll Rand Thermo King. I left there and came to Des Moines, Iowa as the plant engineer in Des Moines.
There you go, where we make Firestone Ag tires. Yeah.
That's correct. I joined Process Systems Development in 2012, and it's been a fantastic journey. But my entire career, both in the Army and in every job, has been in two aspects: engineering maintenance and operational excellence. So I think this opportunity, Director of Maintenance and Plant Support, is really ideally created for what I love to do and what I'm passionate about. It's busy, but it's awesome.
The plants are always up and running, right?
Well, that's a true statement. But it's the fantastic team that really makes it worthwhile. In the factories, in my own department, obviously in Andy's department, it's the team that's really fantastic. So makes it great to be here.
There you go.
Not a better place.
And Andy is part of that team referenced by Joe. So Andy, what is your kind of journey to where you are now, and then what is your kind of focus day to day at Bridgestone?
Yeah, so I grew up in Scottsville, Kentucky, home of Dollar General stores.
There you go.
So you either went to work in a factory out of school or you went to work at DG, and started there designing their stores and their fixtures. It's kind of where my branding comes from. At some point in time, I worked for the marketing team, believe it or not, designing fixtures. It was
logos everywhere. I like it.
And a really smart woman I worked for there is like, you got to brand yourself, you got to brand your department, and so that's where that kind of ingrained in me early in my career. And then went off to a Autodesk training center and designed software training and supported customers all over the world. Bridgestone was one of our customers, and got to know Bridgestone, and they asked me to come in. I started in 2012 full-time and started out fixing a small problem. I started peeling back layers, and I said, hey, we could do a lot of good things if we would fix the bigger problem and not just the symptoms that we were dealing with at the time. And it kind of grew from there. And so my group, we're here to support engineering. We're here to support the plants. And so I like helping people. I think it's a lot of fun. I like Rubik's Cubes. I like that challenge of figuring things out. And we figured out a lot of different things over the years. So we have the laser scanning. We have the XR we're going to talk about today, BIM management, 3D design, electrical design, data management. And so we help everybody globally. So we actually support parent company. We help Japan. We help Europe, Latin America, South America. I can say one day I actually spoke to people in 5 different continents one time. Yeah.
That's the always on mentality here, right? The cell phones and emails are not hidden from anybody at that point. But, well, yeah, I think we'd love to dive in and talk about all that, those different aspects of how we're innovating, how we're evolving the operations, the processes, the tools that we use in our manufacturing locations. We've heard our leaders talk about, as part of, Enlighten is modernizing, evolving in performance and sustainability in a lot of different aspects of the company, end to end across what we do. Green and smart is kind of how they keep talking about. We need to accelerate green and smart manufacturing. So I think this conversation is very much in the smart manufacturing realm. And so I think at the highest level, Joe, what does that really mean?
So green and smart, I'm not going to elaborate a whole lot on green.
We'll leave it to the other guys.
Yeah, in my mind, when I think about green, I think about greenhouse gas emissions and protocols, and it's all about energy efficiency, and it's about carbon neutrality and meeting our publicly stated goals in terms of carbon neutrality. So high level, that's what it is. There's going to be other leaders that talk to you about a lot of details and specifically what we're doing in that space. But in terms of smart factory, I think we think of it in terms of 2 levers, and the 2 levers are like on 2 axes. One axis is that of automation.
Okay.
And the reason we think about automation is as the workforce develops, as the worker pool changes. We've got people wanting to do different jobs nowadays. So it has nothing to do with wanting to hire less. It has to do with having to do the most we can with what we're able to get. So the need for automation is to offset the lack of available labor to do the types of jobs that we're trying to do. But the other lever is the lever of throughput. We always have to make product. We have to make quality product, and the need for that is not going away. So the need for throughput never stops. So whenever you talk about smart is the combination, at least the way we envision it. Smart is the combination of automation and connecting all of the systems that we've got throughout the entire manufacturing organization and utilizing that data to capture insights that help us improve throughput, whether that is to reduce non-operating time, to reduce cycle time, to reduce quality-related impacts to the throughput of the product, et cetera, et cetera. So it's really all about connecting the systems and being able to leverage the insights that we get from those connected data systems. Really, that's the way I would explain the way we look at smart factory.
Andy, you said that when you started, you were working on small problems that were maybe symptoms of bigger problems to uncover. When this team talks about exploring new technologies or finding a solution to a problem, like, how do we go about that process? Is it usually we have an identified problem, so let's go find a solution for it? Or is it we're always constantly evaluating the full end-to-end process to find opportunities to improve? Or is it kind of a blend of both?
Yeah, it's definitely in middle out. So, there's times where we have a problem. Hey, how do we solve this problem? And we'll figure out a technology that can help do that. Then there's other times where we maybe see some technology somewhere, new upcoming technology that's coming out. We said, hey, we think this could help us solve some type of problem. We may not know the exact problem or may have a rough idea, but we see the technology and we say, let's see if we can apply that to fix this other problem over here. And it just kind of varies. It depends on what the situation is. Sometimes the problem comes first. Sometimes we seek technology. A lot of times if we see the new technology, we'll kind of put it, kind of in our portfolio or, the file folder in the back of our brain and go, oh, wait a minute, you're talking about this thing we seen 6 months ago at this trade show, or we read an article online or something like that. We think we can use that to solve this problem. Let's try that out and see how that goes.
We've got this group of extremely talented, skilled, seasoned professionals in my group, maintenance fundamentals leaders. They're highly sought after. We need them in every plant, every day. We can't have them travel. There's only so many of them. Early on, Andy presented some ideas we're going to talk about later in the extended realities realm. And we talked about it from a standpoint of how can we make somebody almost be there? not be there,
Yeah.
but they can be as effective as being there. So we started to pursue this technology, and there was a lot of people that wondered, why are we doing this? What are we doing? But we continued to push and continued to push. And then all of a sudden, this thing called COVID hit. And the idea that extended realities were already deployed, and we already had the capability to have maintenance professionals, have engineers almost be there, was really, really important. So just to highlight, sometimes there's a solution that's needed now, and sometimes there's a problem that's out there we haven't encountered yet that people are thinking about, how do we solve it before it gets here? So are we looking for a solution? Are we looking for a problem? I think the answer is both, as Andy stated. So I just wanted to share
absolutely.
that one example.
Well, and let's talk about, the first kind of item on the list of some of these things that I wanted to dive into is extended reality, right? I think a lot of people these days are familiar with this concept of virtual reality. VR is a more regularly heard phrase. Extended reality or augmented reality or these other versions. I guess, Andy, what is extended reality and how we're using it and some of the applications?
Yeah, so virtual reality, usually the way that's defined is it's a HMD, a device you wear that you can't see through. The screen is all you see. You can't see through it. That's your Oculus. That's your HTC Vives. Then augmented reality, we have the Microsoft HoloLens. That's the headset you wear. But also think about, remember the Pokemon Go game where you could walk around with your phone and you could see the Pokemon.
You're grabbing them.
Yeah, you're grabbing them. That's an augmented reality device.
Catch them all.
Yeah,
That brings me back in time. All right.
Exactly. And then the HoloLens also sometimes is called a mixed reality device that kind of brings both of them together. There are some mixed devices that you can't see through, but it has cameras, so it would project what you're seeing. And then extended reality just kind of became that overarching umbrella to call everything one thing, so that it made it a little bit easier. So we call it XR, or extended reality. Like Joe said, we had the remote assistant stuff. We had it deployed in several plants for just kind of pilots and tests. COVID was coming. We seen it. We had a couple devices at the tower, and we said, all right, let's get these out to these plants. We know this is going to be an issue, but just in case. It's only going to be a couple weeks, but, in case it's a month, let's say.
We were so young and thinking at the time, yes.
Exactly. And so it was hugely powerful when we got that out there. And we were able to do, remote viewing, remote audits, remote training, just with the HoloLens device. And then we had done several design reviews with the virtual reality, where you walk through a machine before you ever build it. We've never, it's kind of funny, we've never saved less than $35,000 when we're doing a VR design review, because we've always been able to find something that was like, man, if we waited until that machine was built, this would have cost us, X number of dollars to do that. Sometimes it's ergonomics. We had a great story I always tell is we have this engineer, relatively tall fellow. He's working with an engineer at the plant, and he was equally as tall. And we take it out to the plant to train on this machine. The operator is about 5 foot tall. And he's like jumping in the VR going, I can't reach that. There's no way I'm going to be able to use this machine. And we redesigned it. Really funny thing is that was one of our early VR design reviews. We went back last year for something, and our guys were doing some scanning, and they were walking around, and he didn't know. My guy didn't know who this guy was. He tells me, he goes, man, we tried that VR stuff, and it was horrible. I couldn't reach anything, and it was all this. Nobody had gone back and told this guy that he actually saved us, I think it was somewhere in the neighborhood of $100,000. And we redesigned the machine based on his comments. And he's like, yeah, the real machine came out and it was fine, and he didn't realize that he was the reason that we changed that, and we found that, and we use that as one of our bragging rights now.
Husky lads everywhere unite. We're making a difference here under 5'5". Fantastic.
Exactly, and we're doing more and more training now. That's the next big thing.
Yeah.
We're training operators virtually. Some of that is because of the workforce. It's a demand. It's not trying to replace somebody. It's younger generation, and new people are coming in that say, I don't want to read through a PowerPoint. I don't want to read through a manual. Fran Jones used to talk about reading through her 3-ring binder. She's like, that was great for me, but I know these young kids come in and don't want to do that. They want to learn in a different way.
Got to touch and feel, right?
Yeah, and this gives us that way to do it, and it's safer,
The other thing that I want to make sure everybody understands is why.
Yeah.
It's not a game. It's not fun. It's not cool. It's all those things.
It can be fun.
But that's not why. The why is, and Andy touched on it, but I want to bring it home. When you have a machine operator that is never logged in to Inventor, which is a CAD software, a three-dimensional CAD software, they don't have a username, they don't have a password, they don't know how to interact with a three-dimensional model. They have no idea how to do design. And you can involve that human being in a design review, and they have the kind of added value that Andy was just describing. That is hugely powerful. So what is one of the biggest things that we get from VR and XR is engagement of non-CAD users in a CAD environment. It is just hugely powerful to bring all of those people in, whether they're on the process side, whether they're on the tire development side, whether they're a machine operator, whether they're a quality person, a safety person, bringing all of those people in that have zero CAD experience, don't know how to participate in a design review. They can't read a 2D drawing. Mm-hmm. Being able to bring them in and collaborate with them on a design, it's tremendously powerful. And Andy shared some numbers that doesn't even touch the tip of the iceberg.
And they're adding value without really knowing that they're adding value, just because you're able to make them a part of the
100%.
process, right?
Yeah,
and
100%.
We talked, somebody was explaining it to me as well. You touched on, Andy, the concept of training, right? And there's the safety aspect on it, which is huge. But when we just think of the efficiency, right, of training a new person to build tires, and there's a number that a tire builder who's been doing it for a number of years can make a day because it's repetition. They know everything that they're doing. But you train somebody up to that point, and if you were to just put them on a machine at the start, they're only getting through a handful a day because they're figuring it all out. But they were sharing that with these extended reality training programs, they're able to go through all these motions with extreme repetition before they even step up to the machine. And so they're already learned, and it's just so much more efficient. I'd have to imagine that's a huge benefit of this as you bring new workforce in.
Yeah, and then also the quality aspect.
Yeah.
We have a very high quality threshold, so you can imagine how many tires we were scrapping as you got the new guy up there and he forgets step 7 of 168 steps. We can train them that muscle memory. And what we do is we train them kind of on the virtual reality first. So they're a virtual machine. They're not out there near anything. Like I said, it's very safe. They learn the steps. When they get to a certain point and they've got the steps to a certain level, then they actually go out to the machine with the HoloLens on. That's where the augmented reality comes in. So the virtual machine goes away, but the steps are still there. Step 1, step 2, step 3, and they can actually see what to do. And it gives them like a little hologram, like arrow, do this next, hit this button next, push this pedal next. And it'll help remind them through those steps so we don't have that scrap and waste to quality as much as getting them up to speed and remembering all those steps. Can you imagine if you had to go over and flip to a paper binder and go, okay, I'm on step 17, page, okay, and now this is what I got to do. And then you got to go back over and do what you're doing. This gives you a heads-up display right there at the user, at the machine, where they should be doing it. And it gives them kind of a Google Maps, go over here. Here's the button over here. It's way over here on the other side of the machine, 30 feet away.
I don't want to downplay how difficult it is to run a tire machine, how difficult it is to build a tire. It's real work, and it's difficult, and it's complex, but people learn it. Yeah. And the fact is, it becomes the normal way of what they do every day. Mm-hmm. What's really challenging for a tire builder, especially when they're learning, if you don't have 15, 20 years experience and you haven't seen all of the different things that happen when the weather changes, all of the things that happen when the tack level decreases or certain components become of different ages and they respond differently. When everything is normal, building a tire is much easier than when something abnormal happens. Yep. So not only can Andy and his team train on how to do the sequence of events and follow the steps and get into the muscle memory when everything is normal, we can also create experiences where you induce a machine jam up, or you induce abnormal material, or you induce a slightly less tacky material, and something becomes more difficult. Something becomes more challenging to an operator, and they can experience that in the VR environment, and they can figure out, how do I respond to an abnormal condition? When they figure out how to respond to an abnormal condition, that's not tire building 101. Yeah. That's like advanced level tire building, and they haven't even touched a tire assembly machine yet. Yeah. So taking it even to that level is what really want people to understand. Yeah. Just creating the sequence of events is great. Muscle memory is great. But being able to throw in the abnormal situations and having people confident in how to respond is just tremendously important as well. Huge confidence builder.
Absolutely. Well, I do want to talk about a couple other kind of technologies that we've maybe seen presented at town halls or some people might know about. If you've been to the Bridgestone Tower in Nashville, maybe one day you saw this Boston Dynamic kind of robot dog marching around on some of the floors. I've seen that associated with autonomous maintenance surveillance and would love to understand that. But we were also talking, and there's so many more things that this type of the robot dog can bring to the table, I guess.
Yeah, let me start with that one in layman's terms, and then I'll let Andy fill in
I
the
thought
blanks
robot
on
dog
this one.
was as basic as we could get,
That's
but
pretty
tell
good.
me more.
We call it Spot.
Okay.
It's got the name Spot. But this idea started with multiple things. But to answer your question directly, yes, this robot has the ability to carry a three-dimensional scanner. It has the ability to carry ultrasonic inspection equipment. It has the ability to carry thermographic equipment. So there's multiple things, and it's not just about maintenance, but certainly maintenance is one of our major focuses right now. But you can send the Spot robot to environments where we don't want people going. If we think perhaps there's an unsafe condition or it is a no entry zone, that doesn't keep you from sending the Spot in there and being able to look at things through the camera, doing infrared inspections, things of that nature. So we're certainly exploring that technology. But one of the most exciting things that we're doing right now is to maintain process capability on several of the conversion assets that are installed in our factories. We have to do validation checks for accuracy control. We have to make sure that the machine is going to perform in a process capable manner so that the products that come off have process capability, of course. This has traditionally been done by millwrights, maintenance technicians, sometimes using contact tools, sometimes using non-contact tools, sometimes using survey equipment, things of this nature. But it's very time consuming. Yeah. And it requires lockout tagout, which means the machine is not operating. And the entire time that machine is not operating, we're not making tires. So the idea that we can, instead of performing those tasks in that fashion, use non-contact three-dimensional laser scanning and compare the last inspection to current inspection or the current inspection to a three-dimensional model or a combination of both, and assess whether something has moved or something needs to be adjusted or not. If it doesn't need to be adjusted, we never have to lock it out. Yeah. So we can continue running. Well, then the idea, we had that project moving forward, and it was exciting, and it was really, really interesting. We've got more than one plant now using that methodology. Andy and I were having one of our normal conversations where you're talking about what if, rather than what. And you say, well, what if we didn't have to go set up the tripod with the scanner? What if we could put a three-dimensional laser scanner on a Spot robot and just give it a route, and the Spot robot goes machine to machine to machine 24/7. It never takes a break. It never takes a nap. All it's got to do is recharge its batteries and go. And we can continually get this data back that says this machine is within its accuracy control parameters. It's good to go. This machine requires an adjustment. It's not in a shutdown, but it requires an adjustment. Right now, we're limited with our ability to get these inspections done based on manpower, based on our stomach for how frequently can we lock them out. It just doesn't make business sense, but we always keep them within process capability parameters. With the Spot robot not shutting the machine down, we can increase that frequency, improve uniformity, improve not having the downtime for the inspections, and the whole thing, it's just all upside.
Human's best friend in so many ways. Look at Spot the dog. I tell you.
Statement.
Well, so on that then, Andy, I mean, that was my next kind of technology to kind of explore, is this idea of 3D scanning or digital twins for entire facilities, right? I think we've talked about digital twins in product before as like a mobility solution where we have a digital twin of a tire to be able to monitor it. But when we talk about digital twinning of facilities, where are we getting with that?
Yeah, so digital twin is one of those words that it's a different definition for everybody. When you're talking to my group and you're talking about engineering, we're talking about the machine capturing that as built or designing that as built. engineers at the plant use it because, if you walk from an engineering office to the top of mixing, it's a 30-minute walk. You come back after you get your measurement, that's an hour that engineer's lost because he got stopped and talked to somebody and, had to come back and enter something into the computer, where now he can just pull that up, measure it in the scan, and he's got it. When we first started scanning, it took about 11 minutes per scan. Now, with the new technology we just got last year, we're capturing a scan every 25 seconds. And so we're capturing terabytes of data in a week. And so we can get exactly how that plant is. Just like the HoloLens, where you don't have to go there, you can actually measure. You can virtually go to that plant and see what they have, look at it, measure it, see how much space you have. And then you can pull that data out and use it in your 3D model and say, will this fit? If I bring this machine through this aisle, is there enough room for me to get it out or get the new one in? If I need to add on to this machine, what would that do to me? And you can check, can I fit a crane in there? Can I fit whatever? And so we have that as-built data with those scans. And the new software also allows us to let anybody see it that has permissions. And so you don't have to have a giant CAD workstation anymore. You can get into a web browser. It's lightweight. Yeah. And you're seeing terabytes of just data that you don't have to fly to Brazil. You don't have to fly to Argentina. You can go there virtually just on your laptop and see what's there and what can we add, what can we take away. We need to take this out and put this in. We can cut that out. Will the new one fit in that space? We can put a 3D model into that scan.
Yeah. And so, with extreme accuracy. It's amazing.
Yes. Yeah. Our scanners are plus or minus 1 millimeter at roughly 350 meters away.
That sounds ridiculous in itself. 300 meters away.
Yes. 350 meters, it's plus or minus a millimeter. So, you're talking about
pretty good.
24th of an inch accuracy at that kind of distance. And up close, it's even more accurate than that.
The conversation we had right before this is on the podcast prior is about digitalization across the company, and it's changing ways of working in this modern world. I mean, this takes that down into the plant level. We talk all the time as we try to educate people outside of Bridgestone or outside of the industry. They think tires are just black round rubber. There's not a lot of innovation in them, but they're extremely technical items and products. You add all of the connected modern world environment to that, and it adds layers and layers. But people would walk into a manufacturing plant and be like, oh, make some tires in here. But everything about the plant is so extremely technical and digital and modernized, and we're continuing to drive it. So it's amazing to see these tangible examples of the stuff that ties all of this aspect together as we work towards constant innovation in the future, right? So, well, what's next? I mean, we're about out of time at this point, but I mean, what else are we exploring, thinking about? These are big things we're already doing. I have to imagine there's other cool things we'd love to get into. Robot cats coming up next.
No, not robot cats. I think whenever you think about an asset on the factory floor and you think about, now we're talking about maintaining it. Well, maintaining it has an indirect impact on how it performs and what it produces. We talked earlier about automation. Mm-hmm. I think one of the things that's next is, how do we put process governance in place such that when we design assets, when we modernize assets and deliver them to the factory floor, they are designed, they are programmed, they have the correct sensing capability, so that before we even buy them, before we install them, we can simulate how they're going to perform. And we can put them into a connected environment and virtually run them. And then we can optimize their performance. I really think that is one of the next things that is coming for us. Think about the difference in a senior leader in the organization comes to an engineer and says, or an engineering department and says, we would like to consider an expansion, or we would like to consider a new plant. And they give you some generic guidelines of what this scenario entails. Today, and in the past, it always starts with an Excel spreadsheet of, okay, what is it going to take to build those tires? What is it going to take to build that product in that volume? And then it morphs into an Excel workbook, and then sometimes into a 2D drawing, a facility layout. Imagine a world when, instead of that, you take that senior leader and you put him in the Vive and you say, let me take you on a factory tour of the factory we're going to build.
Yep.
And oh, by the way, let's run a simulation. And at the end of your tour, we'll show you what product was built during your tour. Thinking like that and trying to get people to be able to more engage on a broader scale in every aspect of what am I going to get from this design that we're working on now is getting all of that data connected and using all of that connected data to get a better answer, a better solution, a better estimate, and ultimately a better result for the business.
It's this idea of, you said at the beginning, why do we do these things? And when you can get the teammates to understand, to experience the why, you get the buy-in to start thinking more the way that y'all are thinking, right? What if on some of these things?
Yes.
Well, I mean, it's exciting stuff to see. I like to take, teammates where we can into the manufacturing sites because not everybody gets to experience it, but to understand when we talk about this E8 commitment and the things we're delivering through mobility solutions and sustainable solutions, but all these things trickle all the way down into activities at every level that are driving this type of mindset, this type of thinking to deliver on all of those values. So really interesting to learn more about it. Thank you both so much for your time. Thank you for the exciting what ifs you're bringing to the to the business, and can't wait to learn a little bit more about it. But Andy, thank you for joining us, and Joe, thanks for joining us as well.
Thank you. You're welcome. Thanks for having us.
Well, like him or hate him, Alabama football coach Nick Saban is one that preaches the relentless pursuit of continuous improvement. And that's exactly what Andy and Joe's smart technology activities are driving in manufacturing across Bridgestone, impacting quality, impacting efficiency, and ultimately helping pave the way for us to create more value for society and our customers. If you liked this chat, be sure to listen to some of our other conversations wherever it is you listen to podcasts. Remember, you can also watch episodes on our Bridgestone America's YouTube page, and wherever you hear us or watch us, feel free to give us a rating or a review and tell us how we're doing. You can also send a question, an episode idea, or just feedback via email. Send it to thrivepodcast@bfusa.com. Thanks for listening. I'm Keith Cawley, telling you as always to keep on keeping on, and remember that at Bridgestone, today, tomorrow, together, we thrive. Be good, everybody.